This is Adam Asif Waziri, and we are here to talk about static seasonality included regression analysis. What am I trying to do today is to start from the figure on the left, which is my actual data, and end up with the figure on the bottom right, which is my actual data along with my forecast. To make the job interesting, I have first created a set of random data here, and therefore these random data are changing. These become different numbers because I wanna make my procedure independent of data such that it can work with any type of data. I mean with any set of data. However, in the middle of this discussion, after we did a little bit practice with random data, then I will copy and paste them by value, and therefore we fix the data. We do not allow them to change anymore, and that is because to make it a little bit more simpler for you to follow. However, right now, when I look at this data, or this data, or this, in all of these data, and I have drawn these data using, of course, I have marked these two here. I have marked these two. These are the data that I have it for 75 periods. This could be 75 days, weeks, and months, and so on and so forth. I go to insert, I go to scatter chart, and I go to this one, and these are my actual data. They have the same pattern, but I can play with them. Okay. If we look at any of these periods, we see that we start from low, we go to a high, and then come to a low. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think if we look at this, we see some seasonality. We see in some periods demand are low, then they go high, and then they come down again. If we look at the numbers, we see that this process renews itself every 5 periods. So it is logical if we assume that periodicity is 5 periods. Just to make my job a little bit simpler, I format the axis, and instead of going up to 80, I go up to 75, and that is because I only have 75 numbers. Okay, make this graph also a little bit smaller. I delete this title, and I delete these lines also. Okay, so now I have a graph of the actual data. Now I want to remove seasonality from this data, find the trend, forecast the trend, and then add back seasonality. Because in this data I see that the data is going upward, and also it shows seasonality. One way of removing seasonality, and here I have 5 period, is to compute average of 5 periods. But if I do this, look, one of the items is 4 period away from this, the other one is 3 period, 2 period. So the farthest piece of data is 4 period away from this average. A better way is if I come to this average, if I forget that one, if I come to the middle point here and say equal to average. Now, if I look at this data, I see that the farthest piece of data is just 2 period away from here. That is better, and we call this centered moving average. Centered moving average. Now if I copy this down, I may come up to here, but this piece of data contains 2 zeros, so I delete that one because in that period I don't have 5 period centered moving average. That is true for this one too, so I drop this one too, and now this last item contains 5 items. It is average of 5 items. Now let me add the data that I just got it to these numbers. So I'll go here, I go select data, add, and then I will go and add y values and their corresponding x values. Okay, and now I have this data without seasonality. Let me just do something simple. Copy and paste, and then I go here, I remove this data. That is my original data. This is seasonality removed data. Now these numbers, they don't have seasonality inside them, but they do have trend. Now I may use regression analysis to estimate the trend of this data. There are 2 ways. Each one has a advantage and a disadvantage. I will go to data. I don't have the software here, so I go to file, I go to options, add-ins, and then I say go, and then I go and I add analysis toolpack, and because I may later need solver, I also add solver, and as we see, they appear here. Now I have data analysis. I go to data analysis and I will say regression. So regression is here. This can be done for any data before deseasonalizing them, or a data that doesn't have seasonality. This is a general procedure when I have some data and I want to conduct a regression analysis, either linear or non-linear, 2 variable or more than 2 variable. Okay, I come here, I say okay, and then it says what are your y values. I go here. Let me first, here at this stage, I want to fix my data. Okay, so I really don't want to have randomized data anymore. This is the last time you see this randomized feature of this data in this lecture. But in order to make your job simpler, I'll go here, I copy it down. I don't need to do, of course, like this. I can go up here, Control Shift down. That is marked. Then I right click, copy, and then I go paste the special, and this one pastes by values. Now here we don't have random number anymore. These are just numbers. So our data will not change anymore. Now I will go and I go to data analysis, to regression. Where are your y values? They're here. These are my y values. Where are your x values? These are here. These are x values corresponding to those y values. Okay. And do you want it in another page, new worksheet, or do you want it here? I want it here because I want to show something to you, and I will say paste it here. Okay. So now regression is done. In regression analysis, we look at I mean, we should look at all of them, but there are some pieces of data which are more important to us, and we first look at it. The first number is intersection, which is here. Let me remove a little bit decimal points. And this is the slope. We call them B0 and B1, and equation of a line is y is equal to B0 plus B1 times x. So this is equation of a line. In this problem, it will tell you that B0 is equal to 944.86 and B1 is equal to this one. Two important numbers for us are here. One other important number for us is r square or adjusted r square. Right now let's just talk about r square, and it is here. Mark it and make it red. So this one is important for us. We want it to be as big as possible, and big means close to 1, because r square is between 0 and 1. The closer to 1, the better. 0.9, 0.94, 0.8, those are good numbers. Low numbers are not good. This one says our computation were based on 71 numbers, but look, in the first 2 months we didn't have anything, and in the last 2 months we didn't have anything. So that is correct. Our count, the number of observations, is 71. Standard error, say, is standard deviation of our forecast. So if I say forecast for the next period is 1200, with that one I can also provide a standard deviation of forecast. That means demand for the next period, average of 1200 and standard deviation of 317, for example. One other thing which is important to us is p-value of B1. P-value of B1. We want it as small as possible. Definitely less than 0.05, 0.025, or 0.01. We want it at those ranges. E and something in front of it means 10 to the power of that number. Here we have E, that means 10 to the power of negative 44. Negative means this happens in the denominator. So this number is almost 2 multiplied by 1 divided by 10 to the power of 44. 10 to the power of negative 44 means 1 divided by 10 to the power of 44, which is a very small number. Then it has been multiplied by 2. So this number is very small, and that is good. We like it to be small. I think these are all I need here. Now if I want to create a regression line for these data, I can do this. I can go here, I can say equal to intercept, which is here, and lock it because I'm going to copy it down, plus slope, which is here, and lock it because I'm going to copy it down, multiply by this value, and don't lock it. Then, and I copy it down. Therefore now I have the regression line. Again, copy and paste it, and then I will go and I delete this previous line which I had, and then I go here, select data, add, and I select this regression that I have provided, and this was the regression line. I have it here. Okay. Okay, and that is my regression line. Okay, this was my original data. Then I removed seasonality and I got this line. These do not have seasonality. Then I applied a regression line on those data. Okay, so if I'm going to have all of them on the same curve, select data, add, and I will go here, and then go down, and then also go down here. So these are all my data, actual with seasonality, removed seasonality but including trend, and then using regression to find the overall trend. Let me tell you something here. We used the regression analysis capability of data analysis. The benefit of this is it will give us coefficient of determination, standard error, and also p-value. But there is a problem. In this procedure, if I make some changes here, for example, if I make this piece of data 1 million, it cannot be 1 million, but I just enter it. No change will happen here. So this table was prepared for the set of data we had, and if we make some changes over there, then there will be no change in these coefficients. Now I can use a different procedure, but the weakness, the benefit of that procedure is it is dynamic. As soon as I change data, it will change. But the weakness is it will not provide me with a table of R square, standard error, and p-value. Let's see what am I going to do. I will type equal to trend, and then it says where are your y, known y values. This were my indeed seasonality adjusted data. These are my y values. Then it says where are your x values, and then x's are here. These are my x values. Okay, and lock it because we are going to copy down. It says what is your known x. It is here. Enter, and then I copy it down. Now in this situation, if I go ahead and change this one to 1 million, it cannot be 1 million over there, but I just want to show if I make a change over there, it will not here in the table when I provided using regression, but here because I used the trend function is dynamic and it will change the results. For example, here I have 1006, that would become 124,000, and all the coefficients will change. So that is the benefit of using trend function. In practice, that is what I will do. I will first use regression to see what is R squared, to see what is p-value, to see what is a standard error, and after that I use just trend function. Now let me see if we can get this data, which is our original data, and get this regression line, and then insert scatter. This is it. Now let me see here. It says at trend line. Okay, here we say display equation on the chart, and that is good. Now I know that it is these values, right? That is, I think, the same thing we got it for using regression. 944, 944, and 61 and a half, 61 and a half. So here I can also have the formula for the regression line. So now we have this. The next step, let me clean up this regression equation from clear all. Okay, now let's see what am I going to do. Regression line, and this is my actual data. Regression line shows the trend, but it does not include seasonality. So if I divide what I have by what I have got on the regression line, what I get can be a seasonality index. So this is my seasonality index. This is seasonality index of period 1, period 2, 3, 4, 5. This is for the next 5 periods. See? Low season, a little bit more than low season, high, and going back to close to low. So I can compute this for all data. Now in each year, in each 5 periods, I have equal to average, control, this one, and this one, and this one, and this one, 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 a little time consuming, but the good news is this: if I copy it down, it will automatically goes to period 2. If I copy it down, it will go to period 3 and 4 and 5. But this was not a very efficient procedure. I clear this one. What I will do, conditional formatting, new rule, use formula equal to if module of this number and 5. Module of this number and 5, that means divide this number by 5 and get the remainder. If that is equal to 1, and then I remove this one, and I remove this one. If that is equal to 1, then format it, say red, okay. Now it is red, and I go and paint the format and copy it down. Now all period ones are red. So now what I can do, I can say equal to average. Now it is easier to mark these numbers. easier, but as you saw, I made a mistake. So maybe the better way is this. First, let me clear this conditional formatting, clear rows from selected cells. Here I am going to write module of this number and 5. Correct? This is module of that number and 5. And that is 1, 2, 3, 4, and for 5 is 0. So I type it over there and I copy it down. So 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0. Suppose I don't like that 0. I will say if this module is not equal to 0, type the module itself. And if it is equal to 0, type 5. Enter. Now I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I remove these decimal points because I really don't need it. Okay. So I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. Then I go here and I type equal to average if. Average if. What is the range you are talking about? I'm talking about this range. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and lock it, comma, what criteria? What is the criteria you want? If this is equal to and this. If it is equal to 1, then add up these numbers and I lock it. So that is average if. You look at here, if it is equal to 1, then average those numbers here. I've got the same thing. Now if I copy it down, 1, 2, 3, 4, 5, this is average for all those periods. This is a better way, an easier way. Now I have the averages, right? And I also have the trend line. All I need now I to put back the seasonalities over the trend line. Look at here, this seasonality is conditional formatting. If it is okay, this is conditional formatting, high, less high, less high, low, and so on. So now I want to put back seasonalities on the regression line and use it as my forecast. Therefore, I write over there equal to, multiply this one by seasonality. And seasonality is here. So for period 1, 2, 3, 4, and 5, it works. So here, this number was 1000 because it is low season, now it is 600. This number was 1067 because it's low season, it is this one. This was this much, which is because it is an average season, it is this one. But if I copy this down, then I have nothing over there, correct? So what should I do now? I go here, I say, get this number, instead of multiplying by h something, multiply it by VLOOKUP. VLOOKUP, and what VLOOKUP? VLOOKUP value is here, and table array is here. Lookup value was there. Table array is here, but we need to lock it because we copied down. That is table array. And what column? Column, this was column 1, this is column 2. So look what you have here, that is the module. Look for the corresponding value over there and multiply by corresponding index. So now if I copy it down, I will get the same number. If I copy this down, I will get the same thing. 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 Now if I copy this down, I should get 1313 multiplied by 0.6. Yeah. Yes. Yes. So I take these numbers and put them here. I will copy this. I will type 1 and 2 and 3 and 4 and 5 over there. I will delete this line, and then here I say equal to VLOOKUP. VLOOKUP, if what you see is here, if what you see, then look at the lookup array, which is here, and then we lock it because we want to copy it down. If it is 1, put the index of 1. If it is 2, put the index of 2. And those indices are in column 2. Enter, copy down. But this should be multiplied by this one. Multiply, enter. Now I have all those numbers, and I can copy it down. Now these were my actual values. And these are my overall final forecasts. What I will do, I will go here. I delete this line. And then I go over there. I say select data, add, and then I will go and add these numbers, which are here. I go up, down, and it's okay, and it's okay. And this is my actual data and my forecast. Given this information, now I can forecast for the next period, which is period 76. So if I type here 76, I can copy this down, and I can copy this down. I should copy this down. So my forecast for next period is 3,374. And that would be my mean forecast for the next period. If I wanted standard deviation, that would be the standard error. Remember, we got the standard error. Data analysis, regression. We have C's as our Y's. We have our X's, which are in column A. And if you want to input it, if I want to branch here, remember this standard error? So now my forecast for the next period has an average of this one, and a standard deviation of this. Demand for next period has a normal distribution with average of this much and a standard deviation of this. Thank you very much. Yes.